Bismillahirrahmanirrahim. Assalamu alaikum student. Today I am going to solve the A-level math paper 3, October November 2023 paper 3. Now let's start the paper. Question number 1 part is sketch the graph of y equal to absolute 4x minus 2. If we take the common 4 here, we can write this x minus 2 over 4. And this will be equal to 4 into x minus 1 over 2 plus 0. And when we compare this y equal to ax plus minus a minus b plus c, this is absolute graph, and the shape of this graph is this when a is greater than 0, and bc is the vertex of this graph. This point intersect the y-axis. We can name it as y-intercept. This value is 0, d. Now we can draw the graph by comparing the graph, given graph here. You see here the y-intercept is BC. Here the y-intercept will be 1 over 2, 0. And the y-intercept we can calculate by substituting the value x equal to 0. Therefore, the y will be equal to 4 into 0 minus 2, and this will be equal to 2. And therefore, the coordinates of y-intercept will be 0, 2. Now we have two coordinates. We can draw the graph by using these 2 points. You see here, these are the x and y axis. And now this is the 1 unit of on x-axis. This is 1 unit on y-axis. This is 2 unit on y-axis. You see here firstly we will mark the points 1 over 2, 0. You see here this is the point 1, and this point will be 1 over 2, and this point will be 1 over 2, 0, and next point 0, 2, this is 0, 2. We will join these two coordinates, and you see here this is the left side of the graph. Now the right side will be symmetrical in the absolute graph. Now you can draw the right side by main symmetrical line. You see here this will be the right side of this absolute graph. Now this is the graph of y equal to 4x minus 2. Part B, solve the inequality 1 plus 3x less than absolute 4x minus 2. We can solve this inequality by taking square on both sides. We can write 1 plus 3x whole square less than absolute 4x minus 2 absolute whole square. We can expand these value by using the identity formula. A plus b whole square is equal to a square plus 2ab plus b square. Therefore, we can write it as 1 square is 1 plus 2 times of ab, 2 into 1 into 3x plus 3x whole square is equal to 9x square. Next is 4x minus 22 is whole square. We can write it as 4x whole square minus 2 into AB, 2 into 4x into 2 plus 2 whole square. Now we can write it as 9x square plus 6x plus 1 less than 16x square minus 16x plus 4. And we shift all values from left to right side. This becomes 16x square minus and 9x square minus 16x minus 6x plus 4 minus 1. Therefore, we can write this 16x square minus 9x square is 7x square minus 22x plus 3 equal greater than 0. And we can find the value of x by try this using midterm breaking rule. Therefore, we can write 7 times 3 is 21. We can write 7x square minus 21x minus x plus 3 greater than 0. We take common, 7x is taken as a common. Therefore, we can write it 7x into x minus 3 minus 1 is a common. And we can write x minus 3 greater than 0, we can write x minus 3 into 7x minus 1, and greater than 0, we can find the value of the inequality by using the quadratic curve. You see here, here is the x equal to 3 and x equal to 1 over 7 are the intersecting points of this quadratic curve. You see here, this is 1 over 7, this is 3. Now we draw the quadratic curve here, and this quadratic curve, the value of y greater than 0, you see here the value of y is greater than 0 will be on this part. This is these on these part, the value of y will be greater than 0. You see here when the x is greater than 3 and here x is less than 1 over 7, these value will be greater than 0. Therefore, we can write this range of values while x is less than 1 over 7 to greater than 3. This is the answer. Question number 2, the parametric equation of a curve x equal to ln t whole square, y equal to e power 2 minus t square for t is greater than 0. Find the gradient of the curve at point t equal to e. Simplify your answer. Gradient of the curve will be equal to dy over dx at x equal to t equal to e, and dy over dx at t equal to e, that's equal to dy over dt divided by dx over dt. And firstly, we will find dy dx over dt. You see here x equal to ln t whole square. We take the derivative on both sides, d over dx over dt. This will be equal to 2 into ln t power 2 minus 1 into derivative of this base ln t. Now we can write 2 into ln t into ln t, derivative of ln t is 1 over t. Now we can write here is t equal to e, here at t equal to e, this value dx over dt will be equal to 2 into ln e into 1 over e, and this will be equal to 2 over e. Next we will find dy over dt, here y equal to e power 2 minus t square. We can write dy over dt equal to e power 2 minus t square. Firstly, we write as it is. Next, we will take the derivative of this power. Now the power derivative of 2 is 0. T square will be 2t. We write minus 2t, and for t equal to e, this value will be equal to dy over dt will be equal to e power 2 minus e square into minus 2 power e1. We can write minus 2 into e power 1, 2 minus e square plus 1. This value will be equal to minus 2 into e power 3 minus e square. Now we substitute the value of t here. Dy over dt is 2 into e power 3 minus e square. And this dx over dt here is 2 over e. We can write 2 into e power 3 minus e square multiply e over 2. 2 will be cancelled, and this value will be equal to e power 3 plus 1 is 4. 4 minus e square. This is the answer. Question 3. The polynomial 2x cubed plus ax square minus 11x plus b is denoted by p of x. It is given p of x is divisible by 2x minus 1. When it is divided by x plus 1, the remainder is 12. Find value of a and b. Firstly, we write the polynomial function here. Next week, here is the factor 2x minus 1 is a factor of this polynomial function. Therefore, we can write it as x equal to 1 over 2. Therefore, the p of 1 over 2 will be equal to 0 because this polynomial is divisible by 2x minus 1. Now we substitute this value 1 over 2 in this polynomial. We can write it as 2, therefore 2 into 1 over 2 power 3 plus a into 1 over 2 power 2 minus 11 into 1 over 2 plus b equal to 0, and this value will be equal to 2 into 1 over 8 plus a over 4 minus 11 over 2 plus b equal to 0, and we can write it as 1 over 4 plus a over 4 minus 11 over plus b minus 11 over 2. We write minus 11 over 2 here equal to 0, and this value will be equal to minus 22 plus 1 over 4 plus a over 4 plus b equal to 0. Multiply by 4, we get minus 21 plus a plus 4b equal to 0, and therefore a plus 4b equal to 21. The next equation, it would be when we divide p of x is divided by x plus 1, the remainder is 12. Therefore, we write x plus 1 equal to 0 and x equal to minus 1. Therefore, p of minus 1, we get the remainder, and this value will be equal to p of minus 1 here is equal to 2 into minus 1 power 3 plus a into minus 1 power 2 minus 11 into minus 1 plus b equal to the remainder here is 12. We write 12. Now we can write it as minus 1 cube is minus 1 minus 2 plus a minus minus plus 11 plus b equal to 12. Now we can write it as a plus b equal to 3. Therefore, a will be equal to 3 minus b, and here is a is 3 minus b plus 4b equal to 21. Therefore, 3b equal to 18. Therefore, b equal to 6. Now, the value of a we can find if we substitute in this equation third. We can write here is a equal to 3 minus 6. That will be equal to minus 3. This is the answer. Question number 4, part A. Sketch the Argand diagram. Shade the region whose points represents the complex number z, satisfying the inequality z absolute z minus 4 minus 3 less than equal to 2 and real z is less than equal to 3. Firstly, we write this here inequality z minus 4 minus 3i, we can less than equal to 2. This equation represents the circle. Now the equation of circle is z minus z naught equal to r. Therefore, the z naught is the center of the circle. Therefore, here is z naught is 4 plus 3i. Therefore, the center will be 4, 3. Now the radius here is equal to 2. Now we draw the circle of radius 2 having center 4, 3. This is the graph. Here we represents the point 4, 3. This point is 4, 3. Now the radius is 2. Therefore, we mark 2 unit above a points, another points 2 unit left, 2 unit right, and 2 unit down. Now we draw the circle by joining these points. You see here, this is the circle, and the inequality z minus 4 minus 3i less than 2. It means the region inside the circle will be the required region, and the boundary of the circle is also included in the region. Next is r is real number, r is z less than 3. Now we suppose that here is the z is x plus yi, is less than equal to 3. Now the real value here is x equal to 3. Now we draw the line here. Real number is x is less than 3. Firstly, we draw the line here, x equal to 3. This is the line which passing through the x-axis at 3, and this is the parallel line to the y-axis, and less than 3. This region will be the left side of the line will be the required region. Therefore, the common region of this line and circle we shaded. This is the shaded region of this inequality, and within this region, these points satisfy the inequality z minus 4 minus 3i, and real z is less than 3. Part B, find the greatest value of argument z for the point in this region. This is the circular region. The greatest value of argument z we can find by drawing a tangent from the origin to the circle. You see here there are two tangents from this origin to the circle. One tangent shows the minimum argument and second tangent shows the maximum argument. Suppose that this second tangent intersect the circle at point P. The length of CP is the radius of circle, and this will be the 90 degree to the circle. And if we draw a line from O to C, you see here the OC, this is OC. Argument C will be equal to the argument of OC, the angle of OC from the positive x-axis. This angle is theta 1, and this angle will be theta 2. Firstly, we find theta 1, then next is we find theta 2. You see here, this is the radius. Here is the radius is 2. Now, if the radius and this length OC is given, we can find this angle. You see here, this theta 1 is equal to tan inverse 4/3, because the height is 4 and the horizontal length is 3. Therefore, we write is tan inverse 4/3. Now this angle theta 2, we can find this angle. If we calculate OC length, you see here OC length will be equal to 4 square plus 3 square, that will be equal to 16 plus 9 square root 25. 25 square root is 5. Therefore, this length is 5. Now we use this right angle triangle. In this right angle triangle, here the OPC length is 2, OC length is 5. This angle theta 2 we can find. This is the hypotenuse, this is opposite side. Therefore, this will be equal to sine theta 2 will be equal to, opposite is 2 and hypotenuse is 5, 2/5. Therefore, theta 2 will be equal to sine inverse 2/5. We write here is 2/5, and this is the value sine inverse 2/5, and this is the argument z. Question find the exact value of x into x plus 1 over x square plus 4 dx. We can write this integration 0 to 6, and we simplify the numerator. We can write x square plus x over x square plus 4 into dx, and we can write this x square over x square plus 4 plus x over x square plus 4, and we take the integral of both terms, now 0 to 6 dx, and this is 0 to 6 dx, and this can be written as 0 to 6 x square over x square plus 4. This is the proper fraction. Improper fraction we convert into proper fraction if we write x square plus 4 minus 4 our x square plus 4. This can be written as x square plus 4 our x square plus our 4 plus 4 0 to 6 minus 4 our 0 to 6 x square plus 4 dx 0 to the other term 0 to 6 x over x square plus 4 dx. Now we can write this 1 dx because x square plus 4x plus 4 over 4 will be cancelled. Therefore, we write 1 dx 0 to x and 4 into 1 over x square plus 2 whole square dx. This is written as it is, plus we can write this as 1 over 2 into 2x x square plus 4. We take the derivative of this x square plus 4. This derivative is 2x. Therefore, if we multiply by 2 and divide by 2, we can write this as, and this is the derivative of the denominator. We can calculate the integration of this value. We use the formula here, f dash of x, our f of x, integral of this expression equal to ln f of x. Therefore, we write this 1 over 2 into ln x square plus 4, and we take the integration of 0 to 6, 1 dx. This is equal to x, and we write that we take the integration of 1 over x square plus 2 square. This we use this formula x square plus a square dx. This will be equal to 1 over a tan inverse x over a. Therefore, we write 4 into 1 over 2 into tan inverse x over 2. Now we apply the lower and upper limits because all three terms having same upper and lower limits, we write 0 to 6. Now we can write this as x minus 2 tan inverse x over 2 plus 1 over 2 x square plus 4 0 to 6. Now firstly we substitute the value of upper limits in this expression. You see here x is 6. We write 6 minus 2 tan inverse 6 over 2 is 3 plus 1 over 2 into ln x square. 6 square is 36 plus 4 is 40. Next we substitute the value 0. You see here we can write it as 0 minus 2 tan inverse 0 plus 1 over 2 ln 0 square plus 4 is 4, and we write this value is 6 minus 2 tan inverse 3 plus 1 over 2 ln 40 minus 0 plus 0 minus 1 over 2 ln 2 square. We can write it as 6 minus 2 tan inverse 3 plus 1 over 2 ln 40 minus 1 over 2 ln 4, and we can write this 1 over 2 is common, the ln, this is ln 4. Now ln 40 minus ln 4, this will be equal to 1 over 2 ln 40 over 4, and this will be equal to 1 over 2 ln 10, and other terms we write here is as it is. Therefore, we write 6 minus 2 tan inverse 3, and this is the answer. Question 6 part A, by sketching a suitable pair of graphs, show that the equation cot x equal to 2 minus cos x has en route x is greater than 0 and less than pi over 2, we can draw the graph. We taking the value x equal to 0 and x equal to pi over 4 and then s equal to pi over 2. Firstly, we take the graph cot x. Therefore, we write here is y equal to cot x. The cot x will be equal to 1 over 10x. Therefore, we write here is 1 over 10 0. That will be equal to undefined. And next is pi over 4. 1 over 10 pi over 4. This value will be equal to 1. And next is pi over 2. Now we put 10 pi over 2. This value will be equal to 1 over undefined. And this value is equal to 0. And next we will take the value of for cos x. Now the cos x for y equal to cot x, and next is y equal to cos x. You see here the when x is 0, take the value cos 0 is 1, cos pi over 4 is 0.707, cos pi over 2 is 0. Now we can draw the graph on a grid. Now you see here, this is the, now you see here, this is 2 minus cos x. Therefore, we write 2 minus cos x equal to 2 minus 1 is 1. 2 minus 0.707, this will be equal to 1.203. And next value is 2 minus 0 is 2. And therefore, we write here is, now we draw the graph against this value. You see here 0, when x is 0, the cot is undefined. When x is pi over 4, cot is 1, therefore we mark the points 1. And when the pi over 2, the cos value, cot value is 0, therefore we mark this point. From infinite to this point, these points, we draw the graph. And this is the graph of y equal to cot x. Next is the 2 minus cos x. You see here, first point will be 1 when the cos is 0. This value 2 minus cos x is 1. We mark this position. Here is 1. Next is when is cos is pi over 4. This is 1.203. 1.203. And next value you see here, cos is when cos is pi over 2, this value is equal to 2. Now we write here is 2. Now this is the position. These are the points of this 2 minus cos x. We join these points. You see here, when we join these points, we get the graph y equal to 2 minus cos x. You see here, these both graphs intersect at 1 point. Therefore, it has only one root. And this is the solution of this part A. Part B, show by calculation that this root lies between 0.6 and 0.8. To check this, the value of the root lie between these two values. Firstly, we write the function, this function, we write in this form. We write cot x minus 2 plus cos x. That will be equal to f of x. Firstly, we put the value f of 0.6. We can write cot 0.6 minus 2 plus cos 0.6. And this value will be equal to 1 over 10 0.6 minus 2 plus cos 0.6. And we can write this 1 divided by 10 0.6 This value equal to 1.46 minus 2 plus cos 0.6. This is 0.825 and we simplify it, we get, and this value is equal to 0.28, which is greater than 0. Next, we see the value f of 0.8. This value will be equal to cot 0.8 minus 2 plus cos 0.8. Now this value is equal to minus 0.332 and this is less than 0 when the function of first value is greater than 0 and the second value is less than 0, the root will lie between a and b, will lie between a and b. Therefore, we can write it here f of 0.6 is greater than 0, f of 0.8 is less than 0. Therefore, root will lie between 0.6 and 0.8. Part C, use the iterative formula x n plus 1 equal to tan inverse 1 over 2 cos xn to determine the correct root correct to 2 decimal place. Give the result of each iteration to 4 decimal places. Firstly, we suppose the value of iterative for the iterative formula here is x1 equal to 0.7 because the root lie between 0.6 to 0.8. We will take the root value in between 0.6 to 0.8. We suppose that the x1 is 0.7. This is the average of these two values. Next, we will put the value x1 in this equation. You see here, when we substitute the value x1 in this equation become x1 plus 1 is x2. That's equal to tan inverse 1 over 2 minus cos x1 equal to tan inverse 1 minus 2 1 over 2 minus cos 0.7. Now this value will be equal to tan inverse 0.806 and this value is equal to 0.8057. 4 decimal place value will be 0.6806. Now we take the third value. Now you see here as when we substitute the value of x2 in this equation, therefore this value become tan inverse 1 minus 2 cos 0.tan inverse 1 over 2 minus cos 0.6806. That will be equal to 0.8057 and this is the x3 value. And next where you see here this value is also equal to 0.6806. Next value when we calculate it, you see here this value is also the same, the above value. Therefore, when the value will repeat, this value will be the root of this iterative formula. Now we have to write the answer in two decimal place. Therefore, 0.6806, we can write 0.68. This is the answer. Question 7, part A, by expressing 3 theta as 2 theta plus theta, prove the identity. In this identity, firstly, we will take the left-hand side and we will prove that this left-hand side will be equal to right-hand side. You see here, the left-hand side here is cos 3 theta and we can write this cos 3 theta is equal to cos 2 theta plus theta. And this cos 2 theta plus theta, we can simplify by using the formula. And from the formula sheet, you see here the cos A plus B equal to cos A into cos B minus sin A into sin B. Therefore, we can write this cos 2 theta plus theta is equal to cos 2 theta into cos theta minus sin 2 theta into sin theta. And we can write this cos 2 theta That's equal to cos 2a equal to 2 cos square minus a minus 1. Therefore, we can write this 2 cos square theta minus 1. And we can write cos theta is written as it is. And the sine 2 theta, we use the formula sine 2 theta equal to 2 sine theta cos theta. And this formula is also given in the formula sheet. You can see from this formula from the formula sheet. Therefore, we write here is 2 into sine theta into cos theta. And next into and sine theta is written as it is. Now next we write here is 2 cos square theta minus 1. When we multiply the cos theta, we get 2 cos cube theta minus cos theta and minus 2 sine theta into sine theta, it becomes sine square theta into cos theta. Now sine square theta, we use the formula sine square theta equal to 1 minus cos square theta. This formula is also given in the formula sheet. Now we put the values sine square theta, we write here is 2 into 1 minus cos square theta, and we write other values as it is. Now we simplify more, we get 2 cos cube theta minus cos theta minus 2 cos theta into 1 minus cos square theta. Now we simplify this minus 2 cos theta into 1 minus cos square theta. This value become minus 2 cos theta plus 2 cos cube theta. And 2 cos cube theta is written as it is, minus cos theta is written as it is. Now plus 2 cos cube theta, 2 cos cube theta, it become 4 cos cube theta minus cos theta minus 2 cos theta, it become minus 3 cos theta, and therefore this will be equal to the right hand side. Hence it is proved the cos 3 theta equal to the 4 cos cube theta minus 3 cos theta. Now we move the next part of this question. Part B, hence solve the equation cos 3 theta plus cos theta into cos 2 theta equal to cos square theta. For theta is greater than 0 and less than 180. You see here the cos 3 theta we can write is as 4 cos cube theta minus 3 cos theta. This is given in the first part, therefore we write here this equation is 4 cos cube theta minus 3 cos theta and plus cos 2 theta into cos 2 theta is written as it is, and cos square theta is written as it is. Now we simplify more this cos 2 theta. You know the cos 2 theta, the formula is that's equal to 2 cos square theta minus 1. Therefore, we can write this 4 cos cube theta is written as it is minus 3 cos theta plus cos theta. Then we write the cos 2 theta in the form of 2 cos square theta minus 1. That's equal to cos square theta. Next we write here is 4 cos cube theta minus 3 cos theta plus cos theta into cos square theta, that's equal to 2 cos cube theta minus cos theta equal to cos square theta. Now 4 cos cube theta plus 2 cos cube theta, it becomes 6 cos cube theta minus 3 cos theta minus cos theta, it would be minus 4 cos theta, and for cos square theta we shift from right to left side, it becomes minus cos square theta equal to 0. Now we can write this. We take the common cos theta, that's value becomes 6 cos squared theta minus 4 minus cos theta. Firstly, we write minus cos theta minus 4. This will be equal to 0. Now we can write this cos theta equal to 0 or 6 cos squared theta minus cos theta minus 4 equal to 0. We can solve this equation by using the quadratic formula because this is the quadratic equation in the form of cos theta. Firstly, we write the formula of the quadratic equation. You know the quadratic equation is formula is x equal to minus b plus minus b square minus 4 ac over 2a. Here we write the cos theta in place of x. We write cos theta equal to minus b. Here is the b is the coefficient of cos theta. This is minus 1 plus minus b square. Here is b is minus 1 square minus 4 into a is 6. C is here is minus 4 over 2 times of a. A is the coefficient of x square. Now we can write this here 1 plus minus 1 minus minus plus 1 plus 6 times 4 is 24. 24 times 4 is 96 over 12. Therefore, we can write it as minus 1 plus square root 97 over plus minus 97 square root 97 over 12. Now we can write this cos theta equal to minus 1 plus square root 97 over 12. And next we write here is cos theta or cos theta equal to 1 minus square root 97 over 12. And cos theta is equal to written as it is. Now we take the theta value here, that's cos inverse equal to 0. The cos inverse 0 equal to 0. Now we write here is the cos theta equal to minus 1 plus square root 97 over 12. We can write this theta equal to cos inverse minus 7 plus square root of 97 over 12. And this value will be equal to 25.3 degree. And next we will take this value cos theta equal to 1 minus square root 97 over 12. This value equal to minus 0.737. Now this is the negative value. We take the acute angle value. Therefore, alpha will be equal to cos inverse 0.737. This value will be equal to 42.5 degree. Now the negative value will be, you see here, the range of theta is 0 to 180. Therefore, the cos will be negative in the second quadrant. Therefore, we write here is theta will be equal to 180 minus alpha, and therefore we write 180 minus 42.5, and this value will be equal to 137.5 degree. This is the answer. Question number 8, it is given that 2 plus 3ai over a plus 2i equal to lambda into 2 minus I, where a and lambda are real constant. Show that 3a squared plus 4a minus 4 equal to 0. You see here the equation here is 2 plus 3ai over 2a plus 2i, that's equal to lambda into 2 minus I. Now we can write it as 2 plus 3ai equal to lambda 2 minus I into a plus 2i. Now we multiply this. Lambda equal to 2 times of a is 2a plus 2 2s are 4i minus ai minus plus minus 2i square, and we can write here is lambda 2a plus 4i minus ai. You see here 2i square, we can write I square equal to minus 1, therefore minus 1 into minus 2 become plus 2, and we can write here is 2a plus 2 into plus 4 minus ai, and we can write here is lambda into 2a plus 2 plus lambda into 4 minus ai equal to 2 plus 3ai. Now comparing the real and imaginary parts, on left hand side the real part is 2 and the right hand side the real part is lambda 2a plus 1, 2. Now we can write here is lambda equal to 2 over 2a plus 1, we can write 2 into a plus 1. Therefore, 2 will be cancelled, and we can write here is lambda equal to 1 over a plus 1. And the imaginary part here is 3ai equal to lambda 4 minus ai. Now we can write here is 3a will be equal to lambda 4 minus a. Now 3a is written as it is. Lambda value, you know, 1 over a plus 1 into 4 minus a, cross multiply 3a into a plus 1 equal to 1 into 4 minus a. Now we multiply 3a into a is 3a square plus 3a minus a is shift from right to left side, it becomes plus a minus 4 equal to 0. We write 3a square plus 4a minus 4 equal to 0, and this is the equation we have to prove. You see. Part B, hence the possible value of a and the corresponding value of lambda. You see here the equation given here is 3a square plus 4a minus 4. We use this equation to solve the value, to calculate the value of a. Now we write here is 3a square plus 4a minus 4 equal to 0. Now we factorize this equation, and we can factorize by midterm breaking rule here. Now we multiply 3 into 4, that's value equal to 12. We take the factor of 12. You see here 6 times 2 is 12. When we add plus 6 minus 2, we get 4. Therefore, we can write here 6a minus 2a in replace of 4a, and other terms we write same. Now 3a square is written as it is, and minus 4 is written as it is, and equal to 0. Now we take common 3a, it become a plus 2, minus 2 is a common, it become a plus 2 equal to 0, and this value a plus 2 into 3a minus 2 will be equal to 0. Now we can write here is a plus 2 equal to 0, or 3a minus 2 equal to 0. Therefore, a equal to minus 2, here a equal to 2 over 3. Now to find the corresponding value of lambda, we use this equation. Lambda is equal to 1 over a plus 1. Therefore, we can write here is 1 over minus 2 plus 1, and this value will be equal to 1 over minus 1, and this value equal to minus 1. Next, a equal to 2 over 3, we write here is lambda equal to 1 over a plus 1. Therefore, we can write 1 over 2 over 3 plus 1, and 2 over 3 plus 1 equal to 2 plus 3, that's equal to 5 over 3. Now we write here is 1 over 5 over 3, and this value will be equal to 3 over 5. Now the value of a is minus 2, the lambda value is minus 1, and the value of a is 2 over 3, the lambda value is 5 over 1 over 3 over 5, and this is the answer. Question 9, the diagram shows the curve y equal to sin x cos 2x. X is greater than 0, less than pi, and the maximum point M where x equal to a. The shaded region between curve and x-axis is denoted by R. Find the value of a correct to 2 decimal place. You see here, this is the maximum position at the curve where the x equal to a, and to calculate the maximum or minimum point on the curve, we take the derivative of this curve. Now the derivative, before taking the derivative of the curve, we rearrange this equation. You see here y equal to sin x into cos 2x. We can write this sin x into cos 2x. We write this formula 1 minus 2 sin square x, and this is 1 minus 2 sin square x. This value becomes sin x minus 2 sin cube x, and we take the derivative of this equation. Now the dy over dx will be equal to sin x, the derivative of sin is cos, minus 2 is written as it is. Now the derivative of sin cube x, firstly we take the power formula, this is 3 into sin square x. Next we take the derivative of this base, this is sin x is cos x, and therefore we write here is cos x is taken as a common, we can write 1 minus 6 sin square x. Now we can write here is dy over dx equal to 0 for maximum point. Therefore, we can write cos x equal to 0 and cos inverse x equal to cos inverse 0, and this will be equal to 0. Now we write here is 1 minus 6 sin square x equal to 0, and this will be equal to sin square x, 6 sin square x equal to 1. We shift this value from left to right side, therefore it becomes positive 6 sin square x. Now we can write here is sin square x will be equal to 1 over 6, and we can write sin square x, sin x will be equal to 1 over square root 6 plus minus square root 6. This will be equal to x equal to sin inverse 1 over square root 6, and this value equal to 0.42. The next value x equal to minus 1 over under root 6 sin inverse minus 1 over under root 6. But this value, we take the acute value, this will be equal to alpha equal to 0.42. Now the negative value, this will be equal to x will be equal to pi minus 0.42. Now you see here, this is the extreme value, or these are the extreme value where the gradient of the tangent of the curve is 0. Therefore, this is the first value, and this value will be equal to x equal to 0.42, and this is the value of A. Now we move the next part of this question. Find the exact area of the shaded region, giving your answer in simplified form. This is the area of shaded region we have to calculate. Now this is the equation of the curve. Firstly, we convert this equation of the curve in this form. We already convert this equation in this form in the part first. Next, before calculating the area, firstly we calculate these intersecting points. Now we suppose that this intersecting point B and C. Now this at this position, the value of y will be 0. Therefore, we can calculate this intersecting point. If we substitute the value B is 0, therefore this value will be equal to sine x minus 2 sine cube x equal to 0. Now we take the sine x is taken as a common. This value become 1 minus 2 sine square x equal to 0, and sine x equal to 0, or 1 minus 2 sine square x equal to 0, we can write here is sine square x equal to 1 over 2, and this value 1 over 2, we can write sine x will be equal to plus minus square root of 1 over under root 2. Now we can write here sine x will be equal to sine inverse 0 at x equal to 0, and next is sine x equal to sine inverse 1 over square root 2, and this value will be equal to pi over 4. The next value, the negative value, will be equal to x equal to sine inverse negative 1 over square root 2. The negative 1 over square root 2 at x equal to 3 pi minus pi over 4, and this value will be equal to 3 pi over 4. Therefore, we write here is x equal to pi over 4, b equal to pi over 4, and at this position c is 3 pi over 4. Now we take this limit to calculate the area of this shaded region. Next, we find the area of this shaded region. Before taking this area of shaded region, we rearrange this equation y equal to sine x cos 2x. In this way, we can take the integration easily. After arranging this equation, we write this equation sine x cos 2x. Here is sine x into 1 minus 2 sine square x. And 1 minus 2 sine square x, we can write here is 1 minus 2 into 1 minus cos square x. And this equation we write here is sine x into 1 minus 2 plus 2 cos square x. And we can write this equation here is sine x into minus 1 plus 2 cos square x. Now we can write here is minus sine x plus 2 into cos square x sine x. We have to calculate the area of this shaded region. Therefore, the area of this shaded region will be equal to A equal to y into dx. Now A equal to integral of BC y into dx. This will be equal to B here is pi over 4, and C here is 3 pi over 4, and the y value here is minus sine x plus 2 cos square x sine x dx. Now we take the integration, we take integration of sine x. the minus sine x, this will be equal to integration of sine is minus cos x, therefore minus sine and minus cos x plus the integration of 2 cos square x sin x. You see here the derivative of cos x is minus sin x. Therefore, firstly we make here is minus sine. Therefore, we can write minus sine x over minus 1. Now we take the integration of 2 cos square x minus sin x. That's equal to cos cube x over 3. Now we write 2 over minus 1 is as it is. Now we can write this value here is cos x minus 2 over 3 cos cube x. We apply the limit here, pi over 4 to 3 pi over 4. Now we substitute the value of limits here. Now we can write cos 3 pi over 4 minus 2 over 3 cos 3 pi over 4 whole cube minus into minus, and we put the lower limit value here in this equation. We write cos pi over 4 minus 2 over 3 cos pi over 4 whole cube. Now we can write here is cos 3 pi over 4 is minus 1 over square root 2 minus 2 over 3 is written as it is minus 1 over 2 square root 1 over 2 whole cube, and this will minus is written as it is cos pi over 4 is 1 over square root 2, and this is minus 2 over 3 cos pi over 4 cube will be equal to 1 over 2 square root 2, and we simplify this, and this will be equal to minus 1 over 2 square root plus 2 over 2 3 square root 2 over 3 into minus 1 over 2 square root 2, that's equal to 1 over 2 square root 2, and minus 1 over square root 2 minus plus 2 will be cancelled, 1 over 3 square root 2, here is 2 is also cancelled. Now we can write here is over under root 2 minus 1 over under root 2, we can write 2 under root 2 plus 1 over 3 under root 2 plus 1 over 3 under 2, it becomes 2 over 3 square root 2. So now we simplify more. You see here, we can write here is multiply this first fraction by 3 to make the denominator same. Therefore, this value become minus 6 plus 2 over 3 square root 2. This will be equal to minus 4 over 3 under root 2. And we can write minus 2 into 2 over 3 under root 2. And we can write minus 2 under root 2 over 3. These values are absolute value, therefore the answer will be in positive value. Now we put the absolute sign here, therefore this value will be positive. This is the answer. Question number 10, the equation for the line L and M are given. Where C is the constant, it is given that the angle between L and M is 60 degrees. Find the value of C. You see here in the formula sheet, and in the formula sheet, this is the formula of the angle between two vectors. Cos theta A dot B equal to A magnitude and B magnitude cos theta. You see here the A and B are the direction vector. The direction vector of the vector L is this 1, 1, 2, and the direction vector of vector of line M here is the minus 2, 4, and C. We name it as B. Therefore, we can write A dot B equal to 1, 1, 2, a dot minus 2, 4, C, and we can write here is minus 2, 1 multiply minus 2, it would be minus 2, 1 multiply 4 is plus 4, 2 into C plus 2C. Now we can write A dot B is 2C plus 2. Next we will take the magnitude of A. The magnitude of A here is 1 square plus 1 square plus 2 square, and this will be equal to square root of 6. And next we take the magnitude B. The magnitude B will be equal to minus 2 square plus 4 square plus C square, and this value will be equal to 4 plus 16 is 20. We can write C square plus 20 square root. Now we put the value in this formula. A dot B equal to A magnitude, B magnitude, cos theta, and therefore A magnitude here is 2C under square root of 6, and the magnitude of B is square root of C square plus 20, and the A dot B here is 2C plus 2. The cos theta, the theta here is 60 degree. Therefore, we write here is cos 60. Now the value, we substitute the value here. The cos 60 is 1 over 2. Therefore, we can write square root of 6 into square root of C square plus 20 into cos 60, that's equal to 1 over 2. Now we shift this value 1 over 2 from right to left side. Therefore, we can write this 2C plus 2 multiplied by 2. This value become 4C plus 4. And this equal to, we can write it as 6C square plus 6 multiplied 20 is 120. Now we take the square on both sides. Therefore, we can write 6C square plus 120 square on right side and square on left side. Therefore, this value become 16C square plus 32C plus 16 equal to 6C square plus 120. Because square root will be cancelled, we can write 16C square minus 6C square plus 32C plus 16 minus 120 equal to 0. We can write it as 10C square plus 32C minus 104, and we divide this equation by 2, we get 5C square plus 16C minus 52 equal to 0. Now we factorize this equation. You see here 5 multiplied by 52. We can write this as 22 multiplied by 26 and multiply by 5. Now we take the factor 26 and 10 for midterm breaking. Therefore, we can write 5C square plus 26C minus 10C, and 26C minus 10C is equal to 16C. Therefore, we write this value instead of 16. Now minus 52 is written as it is equal to 0. Now next we simplify, we take the common here. You see here, say is a common, this value becomes 5C plus 26 minus 2 is take another common, this becomes 5C plus 52 equal to 0. We can write 5C plus 26 into C minus 2 equal to 0. 5C plus 26 equal to 0, or C minus 2 equal to 0. This value is C equal to minus 26 over 5, and this c equal to 2. We have to find the value of c, and this value of c is positive value here. You see here z is a positive constant. Therefore, this value is not possible, c, and negative value is not possible, but this value is the answer. Part B, show that the length of perpendicular from point 6 minus 3 to line L is square root of 11. Suppose that this is point P, 6 minus 3, 6, and this is the line L. The perpendicular from point P to line L, this perpendicular intersects the line at point C, and the coordinate of this point C we can find if we convert this equation into parametric form. This is the line L. The parametric form of this line L, this x will be equal to 3 plus 1 lambda, y will be equal to minus 2 plus 1 lambda, and z will be equal to 1 plus 2 lambda. The coordinates of this point C will be lambda plus 3, lambda minus 2, 2 lambda plus 1. Now we take the distance between CP, and this distance CP will be equal to lambda plus 3 minus 6 whole square plus lambda minus 2 minus 3 whole square plus 2 lambda plus 1 minus 6 whole square, and this length CP, we write CP square, and this value is square root of 11 square, and we can write this 11 minus 3 whole square plus 11 minus 2 plus 3, that's equal to plus 1, lambda plus 1 whole square, and this will be equal to 2 lambda minus 5 whole square. We can write 11 square root will be cancelled. This will be equal to 11. Now lambda minus 3 whole square will be equal to lambda square minus 2 into 3 into lambda, that's 6, it becomes 6 lambda plus 3 square, that's equal to 9, plus lambda square plus 2 lambda plus 1, and 2 lambda whole square is 4 lambda square, 2 into 2 lambda into 5, that's value will be equal to minus 20 lambda plus 25. Now we can write it as 6 lambda square minus 6 lambda minus plus 2 lambda is minus 4 lambda minus 20 minus 24 lambda plus 1 plus 9, 10 plus 25 is 35 equal to 11. This value 6 lambda square minus 24 lambda plus 24 equal to 0. We can write plus 35 minus 11 is plus 24. Now we divide this equation by 6. We get lambda square minus 4 lambda plus 4 equal to 0. Therefore, we can write this lambda square minus 2 lambda into 2 plus 2 whole square. Therefore, this can be written as lambda minus 2 whole square equal to 0. Therefore, lambda minus 2 equal to 0, and lambda will be equal to 2, and this will be the value of lambda, and this value in the here. Now the lambda is 2, we can write 2 plus 3, lambda 2 minus 2, and 2 into 2 plus 1. Therefore, we write 5, 0, 5. Now we can write it as 6 minus 5 whole square, CP length plus minus 3 minus 0 whole square plus 6 minus 5 whole square. Now this will be equal to 1 plus 9 plus 1 square root, and this will be equal to square root 11. Hence, it is proof that CP length equal to square root of 11. Question number 11. The variable xy satisfy the differential equation. It is given x equal to 1, y equal to 1. Solve the differential equation. You see here the differential equation here is x square into dy over dx plus y square plus y. We shift this value from left to right side. This value become minus y square plus y. Now we can write it as minus y square plus y into dx and x square into dy. Now we shift this value from right to left side. Therefore, this value becomes dy over y square plus y, and we shift x square from left to right side. This becomes dx over x square. Now we can write it as dy over y into 1 plus y plus 1 equal to minus 1 over x square into dx. We resolve this fraction by partial fraction. Now the fraction y into y plus 1, we can write it as a over y plus b over y plus 1, and we multiply this fraction by y into y plus 1, we get 1 equal to a into y plus 1 plus b into y. Now we put the value if y equal to 0, therefore 1 equal to a plus b 0, therefore a equal to 1. Next we put the value y equal to minus 1. We take y plus 1 equal to 0, therefore y equal to minus 1, and this value will be equal to 1 equal to a minus 1 plus 1 plus b minus 1. Therefore, minus b equal to 1 and b equal to minus 1. Therefore, we can write this as a over 1 over y minus 1 over y plus 1. Now, therefore, we can write it as 1 over y plus 1 over y plus 1 into dy, and this will be equal to minus 1 over 1 into x power minus 2 dx. We take integral on both sides, and therefore this value become ln y. This is minus ln 1 y plus 1, because 1 over integration of 1 over y is ln y, and integration of 1 over y plus 1 will be ln y plus 1. Now minus x power minus 2 plus 1, this will be equal to minus 1 over minus 1 plus c, and we can write this ln y over y plus 1. This will be equal to 1 over x plus c. Here the initial values, x is 1, y is 1. We substitute here the value of x and y to get the value of c. Therefore, ln 1 plus 1 equal to 1 over 1 plus c. We can write it as ln 1 over 2 equal to 1 plus c, and we write here is c equal to ln 1 over 2 minus 1, and we can write this c equal to 1 over ln 1 over 2 minus ln e, and this will be equal to ln 1 over 2e. This equation become ln y plus 1 equal to 1 over x plus ln 1 over 2e. ln y plus 1 equal to 1 over x minus ln 1 over 2e equal to 1 over x, and this can be written as ln y over y plus 1 divided by 1 over 2e equal to 1 over x, because ln a minus ln b equal to ln a over b. Therefore, we can write this ln y over y plus 1 multiplied 2e equal to 1 over x, and this will be equal to 2ey over y plus 1 ln equal to 1 over x, and this can be written as e power 1 over x equal to 2ey over y plus 1. Now we shift the e from right to left side, therefore this becomes e equal to e power x over e 2y over y plus 1, and this will be equal to e power 1 over x minus 1 equal to 2y over y plus 1. This will be equal to e power 1 over x minus 1 into y plus e power 1 over x minus 1 equal to 2y. Now we shift the value of 2y from right to left side. We can write it as y in minus y power e power 1 over x minus 1 minus 2y equal to minus e power 1 over x minus 1. Now we can take the common y we write here is e power 1 over x minus 1 minus 2 equal to e power 1 over x minus 1. We shift this value from left to right side. This value become y equal to minus e power 1 over x minus 1, e power 1 over x minus 1 minus 2. This is the answer. Part B state what happens to the value of y when x tends to infinity. Give your answer in exact form. You see here the value of y here is y equal to minus e power 1 over x minus 1 over e power 1 over x minus 1 minus 2. We put the value here is e power x is infinity. We can write e minus e power 1 over infinity minus 0 into e power 1 over infinity minus 1 minus 2. We can write minus e 1 over infinity is 0, 0 minus 1 is minus 1, and here is 0, 1 over infinity 0, 0 minus minus 1. We can write it as minus 1 over 1 over e, and we can write it as 1 over e minus 2, and this will be equal to 1 over e over 1 minus 2 e over e will be cancelled. Minus 1 over 1 minus 2e, this is the answer.